symmetrical linear combination of atomic orbital molecular orbitals. That's what that LCAO stands for. Okay, so I don't want you to freak out. Okay, we've got to decide a few things. Okay, first of all, we have to decide if the molecule being shown, the molecular orbital being shown is a pi orbital or a sigma orbital. Okay, so remember, sigma is that the electron density is between the nuclei, electrons, if I can spell electrons between nuclei, and a pi bond is that the electrons are, what they usually show for this one is that the electrons are above and below or in front and behind the plane, but in front and behind is kind of hard to show, right? Electrons are above or below. I should say above and below plane. Okay, so that's the first decision you've got to make, sigma versus pi. The second decision you've got to make is whether something is bonding or anti-bonding. So bonding is going to have no node between the nuclei, okay, and the anti-bonding is going to have a, as we will be looking at it, like a vertical node between nuclei. That means no electron density, UBI, and that's gone straight. Let's go nuclei. All right, so we've got to decide sigma versus pi, bonding versus anti-bonding. Okay, so to name any kind of molecular orbital, your name is going to be whether it is sigma or pi. So that comes first, and then if there is an anti-bonding, you get an asterisk, okay? And then your subscript is going to be the name of the atomic orbital it came from, okay? And that is our system for naming molecular orbitals. So if we look at this one, first of all, we can make a choice of whether it is a sigma orbital or a pi orbital. So if I look at this, the bond is forming between the nuclei, right in here. Therefore, the electron density is not where that bond is forming, is it? So it cannot be a sigma molecular orbital, okay? I'll just leave that there for a second. So it must be pi, okay? Bond. So I'm just going to list the things that we worked out. So we know it's a pi molecular orbital. Okay, so what's the next thing we are going to work out? Is it bonding or anti-bonding? So if it was anti-bonding, you would have a vertical node somewhere in between the nuclei. So there'll be an area along here with 0 electron density. So there's no node, so it must be a bonding orbital. Okay, so we know it's a bonding orbital, we know it's a pi bonding orbital, and one other thing we know, because we've been told, that it's coming from mixing of 3p atomic orbitals. Now remember when you mix atomic orbitals, like if you have atomic orbitals on one atom and atomic orbitals on the other atom, they mix to form a bonding molecular orbital that's lower in energy than the atomic orbitals it came from, and an anti-bonding that is higher in energy, right? So as soon as we selected the bonding molecular orbital, we know it is lower in energy than the atomic orbitals it's come from, right? Atomic orbital, this is just generic, right? Atomic orbital, this is my bonding MO, and that is my anti-bonding MO on the top. All right, so can we answer the questions now with what we've worked out? Write the symbol for this MO. So to write the name, I'm going to actually kind of try and draw it. We know that it's a pi MO, so I need to write that it's a pi. We know that it's bonding, not anti-bonding, so no asterisk. And then the subscript is going to be 3p because it's come from overlap of 3p atomic orbitals. So that's all I'd have to write for that. Is it a bonding or anti-bonding MO? We know it's bonding. We already worked that out. So is the energy of this MO compared to the energy of a 3p atomic orbital higher, lower, the same, or not enough information to decide? It must be lower. Okay, bonding MOs are always lower in energy than the atomic orbitals that they came from because forming the bond is energetically favorable. So I want to do another one because I know this is kind of a tricky concept to get your head around to start with. So let's try and work out everything we need to know about this molecular orbital. So is it a sigma molecular orbital or a pi molecular orbital? The electron density is along the bonding axis, so that is telling me it is a sigma molecular orbital. Okay, next, is it bonding or anti-bonding? So we've got to look for, is there a node between nuclei? And yes, there is. This is what a vertical node looks like. Look, no electron density in between the nuclei, to a whole line you can draw perpendicular to the bond axis with no electrons. So there is a node. The node means that it's an anti-bonding MO. Therefore, it is at higher energy than the atomic orbitals that it's formed from. All right, so I think we now have all the information we need to proceed. So what is the symbol for this MO? Well, it's a sigma molecular orbital, so we're going to write the sigma symbol. Is it bonding or anti-bonding? It's anti-bonding. So we are going to draw an asterisk, or a star if you prefer, to denote that it is anti-bonding, and then the last thing is a subscript to say the atomic orbitals that it was formed from, and we're told that the question is formed from the 3p atomic orbital. So we have a sigma star 3p molecular orbital. Is it a bonding or anti-bonding MO? It's anti-bonding, which means its energy is higher than the molecular orbitals from which it was formed.